For centuries, we looked at the stars and wondered, are we alone? Are there other worlds like ours, orbiting distant suns? In 2016, astronomers found the closest possible answer. Just 4.24 light-years from Earth, a stone's throw in cosmic terms, a planet orbits our nearest stellar neighbor. It's called Proxima Centauri B. It's rocky, Earth-sized, and sits in the habitable zone, the region where liquid water could exist. But is it truly another Earth? Or is it something else entirely? This is the story of our closest cosmic neighbor. And the question that haunts astronomers, could we ever call it home? The discovery came from the European Southern Observatory's La Silla facility in Chile. Astronomers were studying Proxima Centauri using the radial velocity method, measuring the tiny wobble in the star's motion. After years of observations, the signal was clear. A planet with at least 1.3 times Earth's mass, orbiting every 11.2 days. That's much closer than Mercury is to our Sun. But because Proxima Centauri is a red dwarf, this places the planet in the habitable zone. The discovery made headlines around the world. For the first time, we knew of an Earth-sized planet orbiting our closest stellar neighbor. To understand Proxima B, you have to understand its sun. Proxima Centauri is a small, cool, and incredibly long-lived star. But it's also temperamental. Red dwarfs are prone to powerful solar flares that release enormous amounts of radiation. Proxima Centauri's flares can be hundreds of times more powerful than our sun's, and Proxima B feels their full fury. This single fact may determine whether the planet is a potential second Earth or a radiation-blasted wasteland. In this documentary, we'll explore every aspect of Proxima Centauri B, from the science of its discovery to the dream of sending humans there, from the brutal challenges of its environment to the solutions for survival. We'll imagine the 100-year journey, the first footsteps, and the birth of a new branch of humanity. This is Proxima B, 4.24 light-years. It sounds almost close, just 4 years at the speed of light. But light-years are deceptive. 1 light-year is 9.46 trillion kilometers. Multiply that by 4.24 and you get 40 trillion kilometers. 40,000 kilometers. To put that in perspective, the distance from Earth to Pluto is just 5 billion kilometers. The Voyager spacecraft would take over 70,000 years to reach Proxima B at their current speed. The distance defies human comprehension. With current technology, reaching Proxima B is impossible. The fastest spacecraft we've ever built, the Parker Solar Probe, would still take 6,300 years. That's longer than recorded human history. To reach Proxima B in a human lifetime, we need breakthroughs, nuclear fusion, or light sails pushed by lasers. We need something we haven't even imagined yet. Breakthroughs that transform our understanding of the possible. One proposed solution is the Generation Ship, a spacecraft so large that multiple generations can live and die during the journey. The Helianthus, as envisioned, carries 4,752 colonists on a 100-year voyage. 7 generations are born, live, and die on board. They know only the ship, the recycled air, the artificial gravity, the same faces day after day. Their descendants will be the ones to finally step onto an alien world. It raises profound questions. Would those born during the journey feel privileged to be part of humanity's greatest adventure? Or resentful of a destiny they never chose? A life confined to a hull of steel and glass, 40 trillion kilometers from home. A 100-year journey presents another challenge: genetic diversity. With only a few thousand settlers, maintaining a healthy gene pool requires careful planning. Genetic counseling becomes mandatory. Gene editing might be necessary to eliminate hereditary diseases. Every life is a building block for the future. Cryogenically stored genetic material from Earth could introduce new traits long after departure. The Helianthus carries the entire genetic future of a new branch of humanity. They are the bridge across the void, the pioneers of the great emptiness, carrying the spark of Earth into the deep unknown. Let's look at what we actually know about Proxima Centauri B. It has at least 1.3 times Earth's mass, making it a rocky super-Earth or mini-Neptune. It orbits its star in just 11.2 Earth days. Its orbit is incredibly close, just 7.5 million kilometers from the star, compared to Earth's 150 million. But because Proxima Centauri is so much dimmer than our Sun, that close orbit actually places it in the habitable zone, where liquid water could exist. The habitable zone is where surface temperatures could allow liquid water. Around our Sun, it stretches past Mars. Around a red dwarf, it's much closer and narrower. But being in the habitable zone doesn't guarantee habitability. Venus is in our Sun's zone, and it's a hellish pressure cooker. Mars is a frozen desert. History matters. Here's where things get complicated. Because Proxima B orbits so close, it's almost certainly tidally locked. Just like our moon is locked to Earth. One hemisphere perpetually faces the star, the other away. Between them lies a narrow ring, the twilight zone, where the star hangs perpetually on the horizon. If Proxima B is habitable anywhere, it's probably in this narrow band of eternal twilight. Here, the temperature might be just right. But the biggest threat may come from the star itself. Red dwarfs are volatile. They produce flares that release more radiation in minutes than our Sun does in hours. Proxima's flares can be hundreds of times more intense than our Sun's. Orbiting so close, Proxima B is directly in the firing line. These flares could strip away any atmosphere, bombard the surface with deadly radiation, and make life, as we know it, impossible. Some scientists think Proxima B may have lost its atmosphere long ago, leaving it a barren, irradiated rock, barren and silent. There's another problem, the past. When Proxima Centauri was young, it was much hotter and brighter than it is now. For billions of years, the planet endured extreme conditions. Any water or atmosphere it once had could have been boiled away long ago. Some models suggest Proxima B could be more like Venus than Earth, a hellish world with a thick, toxic atmosphere, a world of secrets. We won't know the truth until we can study it directly. Until then, the mystery remains. Imagine the departure. Thousands of colonists have said goodbye to Earth forever. They've watched their home planet shrink to a dot, then disappear entirely. Ahead lies only emptiness, 100 years of emptiness. The helianthus accelerates, reaching 4.24% of light speed. Then the engines shut down, and the long coast begins. For the next century, they'll drift through the void, carrying humanity's hopes. Life aboard the helianthus is carefully structured. The rotating habitat ring generates artificial gravity through centrifugal force. Inside, the ship is a self-contained world. Farms grow food, factories recycle waste, schools educate children who will never see Earth. The population is carefully managed, births planned, genetic diversity maintained, resources rationed. 7 generations will live and die here. The first generation, the ones who actually left Earth, carry memories of home. They remember blue skies and green grass, the smell of rain. But as they age, their numbers dwindle. Their children know only the ship. To them, Earth is a legend, a place in stories. By the time the ship reaches Proxima B, no one on board has ever seen their destination or their origin. The journey has become their home. With only 4,652 initial colonists, genetic diversity is a constant concern. Strict guidelines govern reproduction and matching. Gene editing eliminates hereditary diseases and could eventually enhance resilience to the conditions awaiting them. A carefully managed experiment. 50 years in, the ship is halfway to its destination. No one on board remembers Earth. The stories have become traditions and myths. Some wonder if they'll ever actually arrive, if Proxima B is real, or just a story to give meaning to their existence. But the data says yes. They're on course. In another 50 years, their descendants will see a new sunrise. The journey continues. The destination is calling.